Hi, we're HEATfficient. I'm Connor Jones, and I'm a mechatronics major.
Hey, I'm Austin Nordyke. I'm engineering technology management.
Hi, I'm Kendra, and I'm a civil engineering technology major.
These past 2 semesters, we've been working with Case New Holland here in Wichita, Kansas, and have identified various problems that we wanted to tackle and focus on for the senior design project. We decided to focus on an issue with their paint drying process and trying to make it more energy efficient. From that, we came up with a statement of how might we create a way to better reduce the energy consumption of the paint drying process in product manufacturing. Because of the way that the oven curing system works in CNH, with an open entry and exit point, the oven is very inefficient and allows hot air needed to cure the parts to escape.
While researching other oven types and various manufacturers who use similar processes, we were able to discover that this problem is the most prominent in older oven systems, and that many newer systems use batch curing in the oven that has a door so that they can close it and put parts in and out without losing any heat. Very few manufacturers in Wichita areas use the older systems like CNH. Upon further research, we found that many manufacturers have upgraded because of how inefficient the old oven is, therefore reducing the number of manufacturers with this problem.
CNH asked us to come up with a solution that would help reduce energy consumption, leading them to an increase in savings. We know the basics of the problems and that heat was freely flowing out of the oven on the front and the back, and that creating a way to contain the heat in the oven would be ideal. Outside of that, CNH wanted us to provide them with rate of return for their investment and implementation of a solution.
To come up with ideas for a solution, we held a design thinking session and brainstormed all ideas we could think of, no matter how realistic or crazy. From there, we took all of our ideas and prioritized them with solutions that were feasible and actually aligned with the needs of CNH. Once we settled on a solution, we reworked and tweaked our design to come up with the best iteration.
Some of these concepts that have been considered were IR laser profile scanning drying, induction heating, or a door that can open and close based off of laser measurements, powder coating, or insulation.
Based on observations while at CNH, we know that it would not be possible to put a physical barrier at the opening of the oven, as parts entering the oven have fresh paint on them. This is not a problem at the end as parts have been cured. However, we realized that we would need a malleable product that could also withstand high temperatures. Based on this information, we looked into other products that produce heat that need to be contained. We came across pizza ovens. Pizza ovens utilize an air curtain or air knife at the opening and closing of them to keep the heated air inside that's needed to cook the food. When looking more into air curtains, we found out that they are popular in drive-thrus, store entries, and cold storage warehouses to keep flying insects out and create a temperature barrier between the inside and outside. We dove deeper into air curtains to see if the specifications could meet our needs. For the exit of the oven, we started brainstorming industries that have high temperatures and who need to create thermal barriers. We found that high temperature heat resistant clothing is made out of aluminized Kevlar. Looking more into that, we realized that for the price, this material would be suitable for our needs.
After looking at all of our ideas, we knew that some of the solutions from brainstorming would not be practical. In the end, we settled on installing an air curtain at the opening of the oven and an insulated physical curtain at the exit. CNH had expressed that they did not want the solution to be costly and something that they could potentially do or install themselves. This is due to the company planning and updating for their painting process in 5 to 10 years to a different curing process, and significant investment in new oven technology at this point would not be ideal.
Many standards will be met. For the air curtain, the unit chosen complies with the Air Movement and Control Association Standard 220. It is also UL certified, as well as having the UL Environment and Public Health designation, making it compliant with the NSF and ANSI Standard 37. International Organizations for Standardization, also known as ISO, has any standards for regulations that also must be met for the installation of the air curtain in an industrial setting. For the aluminized Kevlar material, other standards will have to be met. These standards will depend on the exact material we choose for the final install. As we're not using material to protect the human bodies, there are going to be fewer restrictions on this material. It will have European standards and ISO certifications. Other ISO standards that are relevant to the aluminized Kevlar curtain are currently being reviewed by the ISO technical committee.
As noted before, we found from our interviews that this problem is limited to older model drying ovens with open systems. As there is not an abundance of these systems in Wichita or any particular city or state, the solution is not something that we see could become localized business. Alternatively, it would be better as a business as an online product, so other companies could input their oven operational specifications, and the solution could be designed specifically for it and then shipped to that company. As many companies are switching their systems to newer styles that do not have this issue, a business offering the service would have a fairly short life.
So for the prototype that I created, it's just for a visual to show people, because they can't really envision a 300-foot oven that works. So this prototype was created, and the box is representing the oven, and then we've got a little space heater that is the burners that are inside the oven. As that travels inside the oven, there's a plastic material that's been you can snap on and off the oven that represents the curtain, the Kevlar curtain. The air dryer is to represent what the air curtain would be doing.
So a big part of what I worked on was the finite element model in SolidWorks. So for this, I modeled part of the oven and created an air curtain inside that oven to basically change the variables so that we could optimize the function of the oven. And as you can see in the model, in the original analysis, it shows the sort of penetration of the outside air into the oven. It goes all the way to the back. You can see that lower temperature green going all the way back there. And then after refining the model a bit and determining that about 60 feet per second air curtain was what was ideal to keep these two areas separated, you can see in the second model that the oven is containing quite a bit more heat, up above 200 consistently throughout that oven.
It is our final recommendation for CNH to install an air curtain at the opening of the oven that operates at 60 feet per second and spans 90 inches across. On the exit of the oven, insulated aluminized Kevlar should be installed in strips. This will allow for heat to be retained in the oven while allowing moving parts to exit without receiving damage.
We fully believe that this product is a crucial fix that CNH needs to implement. A heavy amount of research and testing has been done on this and proves that these products to be worth CNH's purchase. With testing, product selection, bid sheets, and payback period calculations have all been finished, the final step is to create a report with these findings and present it to CNH. With our proposed solution, CNH can expect a rate of return of 17% once installed and working properly. Our final solutions will allow CNH to reduce the energy consumption and lower their costs. We look forward to working with CNH moving forward and will gladly give any assistance needed by CNH when purchasing the products or during the installation process.
From all of us at HEATfficient, we thank you for your time and look forward to hearing any feedback that you may provide.